Hello friends, welcome to our website automationcommunity.com. Today we are going to see another example which is fill, mix and drain application using the PLC. So as you can see over here, first of all I have created one HMI screen for our process. So there is start stop button, solenoid valves to fill the tank, 3 level sensors to detect the level of the liquid and one drain solenoid valve to drain our batch. Some indications to show the process like filling process is on, mixing is on, timer value and the drain process. So let us understand our problem definition. So first of all, as soon as the user will press this start button, so what should happen? Solenoid valve 1 should be energized to fill the tank. As soon as the level of liquid will rise, initially you can see this level sensor was off, but as the level will rise, this level sensor will become on. Now it will fill up to this level, and when this level sensor will become on, it will stop this solenoid valve. That means de-energize it and it will energize this solenoid valve so that another liquid can start filling the tank. Right now it is the filling process, so you can see the filling indication is on over here. So similarly you can see from here, as soon as the liquid level risen above this level sensor, it has become on. So this solenoid valve, so when this both level sensors are on, at that time this solenoid valve should become off. This sensor is off and this sensor is on. In this condition, this solenoid valve should become energized and it will start filling another liquid into the tank. After the liquid level rises above this high level sensor, this sensor will become on. So what it will do, first it will stop this solenoid valve. After that it will start the timer. It will start the timer and the motor, you can see the motor is started. So it will mix the liquid up to the desired timing set in the timer, and it is showing the mixing process is on. After the timer value is completed, motor will become off and this drain valve will become on. So you can see from here, timing is completed, so drain process is on, that is indicated from here. Motor is off and drain valve is on, so liquid level will decrease. As the level will decrease, these sensors will become off, and finally when the level is below this low level sensor, that means the tank is empty completely, it will also become off. So it will come back to this original position, and if these both sensors are off, this solenoid valve will start filling the tank, and so the process will be repeated. We will understand the input wiring required for our project. So first of all, again refer to this image. What you can see, there are the 2 inputs as a start stop and 3 inputs as a level sensor. So this is how we can decide the inputs. So here also first of all we will place start stop button and 3 level sensors. Now this is the digital inputs of our PLC. First of all, in the source sink, we will connect the ground terminal of our SMPS and we will take 24-volt positive supply and connect it to one terminal of each input. Now we will connect the another terminal of start button to the X0 position, stop button to the X1 position, this low level sensor to X2 position, this level sensor 1 to X3 position, and this level sensor to X4 position. We have to remember this address while doing the programming. Now, as you know, there are the 3 terminals in the level sensors, common, NO and NC. So here we have taken common and NO terminals for each level sensors. Now again, referring to this image, how many outputs you can see. So our main outputs are this two solenoid valves, this motor and this solenoid valve. So we have total 4 outputs. So let us understand our outputs. These are the digital outputs of our PLC. First of all, from common we will connect to ground terminal of SMPS. Now from Y0 we will on our motor, but we cannot on motor directly from this terminal. So by using Y0 we will energize one relay, and this relay will energize the contactor of motor. So here you can see we have connected 24 volt supply to each output and also to one terminal of the relay. When Y0 will become on, it will provide this ground path to this Y0 and at this terminal, so this relay will be energized. Same will be applied to other outputs. If Y1 is on, then this common will be provided to this Y1, and this Y1 will provide this common to here, and this solenoid valve will become energized. So similarly, I have connected it to Y2 and I have connected this to Y3 position. Now here the output side of the relay, you can see common, NC and NO terminals. So in the common terminal of the relay, we will connect 230 volt phase, and at the NO terminal, we will connect it to one terminal of the contactor. Another terminal of contactor is connected to neutral. So neutral is always provided. If this relay will become on, common and NO terminal will become closed and it will provide power to this contactor. So this is the motor circuit. This is the dual starter for the motor. MPCB works. MPCB has the combined features of MCB and OLR. After that, power will go to contactor, and from contactor it is going to motor, and the contactor is energized from this relay. So let us understand the logic required to create this project. So first of all, we will form one latching circuit to see whether the process is on or off by using two inputs, that are start button and stop button. After that, we will check if the process is on and both low level sensor and level sensor 1 are off. That means this compulsory. If these three conditions are met, then solenoid valve 1 should become on. So this is the logic to start the solenoid valve 1. Now we will write a logic to off this solenoid valve. So what are the conditions to off this valve? First of all, if the stop button is pressed, that means the process is off, then it should be off. Or that means we will connect a parallel path. This is the one condition. What is the another condition? So another condition is if both level sensors become on. So I have connected the end. If this is on and this level sensor is on, then turn off the solenoid valve 1. Same logic we will write for solenoid valve 2. When this become on, if process is on and low level sensor is on and high level sensor should be off. So we will connect these three contacts in series. If these three conditions are met, then solenoid valve 2 should be on, and when it should be off, either the process is off or both level sensors become high, then this solenoid valve should become off. So this is all about the filling process. Now we will understand the mixing process. So first we check if the process is on, then we will check and high level sensor is on, then we have to turn on the timer and also the motor. So motor we have turned on using this logic. If the process is on, high level sensor is on and timing is not completed. So what is this? This is just the NC bit of the timer. If the timing is not completed, its NC bit will have continuity and it will on the motor. When the timer will become on, this NC bit will become off and it will off the motor. And here we can see the logic for solenoid valve 3. If the process is on and timing is completed from here, if the timer will complete, then solenoid valve 3 should be on. Now when this solenoid valve will become off, so again there are the two conditions. Either the process is off or liquid level goes below the low level sensors, so the level sensor will become off. So either this or this condition is met, then we have to turn off the solenoid valve 3, that means drain process. And we also have to reset the timer so that process can start from the beginning and repeat itself. So this is all about the logic. Now let us start creating the ladder diagram of this project. So first of all, I will open my ISPsoft software from here. So first of all, let us click on the new file, confirm yes, write the name of our project, click OK. So as usual, first of all we will write the device command list. So double click over it and this dialog box will open. So X0 is our start button, X1 is our stop button, X2 is our low level sensor, but I will just write low sensor. X3 is our level sensor 1, so I will write level 1 sensor. And X4 is our high level sensor, so I will just write high sensor. Now click on the outputs. So our first output is our mixing motor, so here I am just writing motor. Y1 is our solenoid valve 1, that is the filling valve, so I will write SV1 fill. And Y2 is our second solenoid valve for filling process, and Y3 is our third solenoid valve for drain process. And we have used one timer for mixing purpose, so here I will write mixing time. So that's all for device command list. Just close this, click on the program files and right click on it, click on the new file and just click on the OK over here. So first of all, let us maximize this and zoom out. Now write a network command list over here, form a latching circuit for process on or off. So press enter. So what is the latching circuit? So let us form this. First select the contact from here, bring your cursor to this red portion and make a diagram like this in one output coil. So this kind of network is called latching network. First of all, let us give its address. This is our start button. This is output we want to latch. This is our stop button. And again the output that we want to latch. So again in the device command list, let us give device command for our M0, that is our process on or off. Again come to program file. So how this works, when we press this, first of all let us make the NC over here. Now when we will press this, power will flow from here and it will on, and when we will release this, because this is on, power will flow from here and it will continuously remain on. And when the stop button is pressed, there will be discontinuity of power and this will be unlatched. That means off. That's why this is called the latching circuit. Now insert a network. Write a network command over here. Turn on solenoid valve 1. Press enter. So what are the conditions for turning on the solenoid valve 1? So first of all, setting output over here. That is our Y1 solenoid valve 1. Okay. So what are the conditions? So our first condition is process should be on, low level sensor should be off, and level 1 sensor should be off. So first of all, we have to select the NC, because when this is off, then it should be on. Now let us write the address. So this is our process on, this is our low sensor, and this is our level sensor 1. So if all these three conditions are true, then our this valve will be on. So we have to set over here, then this will be setted. Now when this should be reset, or this valve should be off. So insert a network from here, write a network command, turn off SV1. Okay. Our first condition is if the process is off, then valve should be off. Or what is the another condition? If both these level sensors become on, at that time this valve should be off. So now select the output coil and give address to each element. If process is off, that means we have to select the NC over here. If process is off, then this NC will be powered and this will reset our output SV1. We have to select reset over here. Or what is the another condition? If both these level sensors become on, so we have to use NO context only. Just write the address. So in this condition, this valve should be resetted or off. Now same logic we will write for solenoid valve to fill. So insert two networks. First here, turn on SV2. So again we will use three contacts and one output coil. Now what are the conditions? So first, process is on, level sensor 1 should be on and high level sensor should be off. So here we have to select its NC, and here it is our output Y2. These things you can know from our logic table explained in PPT. Now we have to turn off this solenoid valve 2. So again, what are the conditions? So same like this, select the contacts. First, if the process is off, then valve should be off. Or what are the other conditions? If both these level sensors become on, then this valve should be off. So same like before, you have to select NC over here for process off. It is our M0. Here it is X3. This is the X4 high level sensor, and this is our output Y2. And we have to select set over here and reset over here. Now insert a network. Now we will write a code to indicate the filling process. So how we come to know that filling process is occurring? So either if Y1 is on or the Y2 is on, we can understand that filling process is operating. So select output coil from here. So for this indication, we will use the internal relay M1 only, and two inputs is Y1 and Y2. So either of this valve is operating, that means this is the filling process. Now again insert a network from here. We will write a code to start a timer and motor. So first of all, here I will write start timer. So what is the first condition? That is this should be on and high level sensor should be on. Let us write its address. If these two conditions are true, then our timer should start. So click on the functions block, select all types and write over here TMR and insert. So our timer block is inserted. Here we will write the timer number. We are going to use timer T0. Now here we have to write the timing value. So actual process the timing is larger, but for simulation purpose let us select the 5 seconds. So this is the 100 millisecond timer. So 50 into 100 milliseconds means 5 seconds. So this will on the timer. Now insert a network. Logic for motor, mixing motor. So what is the first condition for the motor? That is process should be on. What is the another condition? High level sensor should be on. And what is the third condition? Timer should not be completed, because we are here using a kind of off delay. So until the timing is not completed, that means 5 seconds is not completed, motor will remain on, and when the timing is completed, motor will be off. So when the high level sensor is on, two things will occur. First, motor will be on and timer will be on. Until the timer will complete its timing, motor will remain on. As soon as the timing will be completed, motor will be off and drain valve will be on by this timing bit. So here select output coil. Now give its address to each point. This is high level sensor should be on and timing should not be completed. So here we have to select the NC bit, and this is our output Y0, that is motor. Now here no need to select set or reset, because this will be on off from this logic only. Now again insert a network. Here we will write turn on solenoid valve 3, that is the drain process. So when the drain process should on, if the process is on and timing is completed, that is it. So select output coil, give address to each item, time is completed, and the output is Y3. Okay. Now insert a network and we will write code to turn off drain valve, that is SV3, solenoid valve 3. So as usual, the first condition, if the process is off, then valve should be off. What is the another condition? When tank is completely drained, that means the low level sensor will become off. So that will be in parallel. So this is the first condition, or when the low level sensor become off, then our valve should be resetted. So here first of all let us select set and here we will write Y3 reset. So what is the first condition? Process should be off. So here also we have to select the NC. What is the another condition? That is the low level sensor, which is X2. When this goes from on state to off state, so means there is the falling edge. If the falling edge of low level sensor is detected, this should be resetted. And what is the other thing we want to reset? That is our timer. Because once the timing has completed, timer value will be 50. So we have to clear that timer value. Here I will write T0 and here also we will reset. So friends, this is all about the ladder logic required for field mix drain application. Its simulation and HMI designing we will see in the next part of this video. Till then, if you like our work, show your interest by liking and subscribing our YouTube channel instrumenttools.com and automationcommunity.com.